Okay. So, we are doing parallel programming in a distributed memory system. Okay. So, we discussed distributed system, we have processors, in fact, it need not be one processor, several processors, but they are in different nodes. Okay. So, but we want, well, I am discussing the several ways that communicate with each other. One of the ways is any node, any processor communicates with any other processor. This is called point to point, right? I mean, there are 2 points, processor is a point. So, there is point to point communication, but there is only 2 parties involved, not collective. Okay. So, point to point communication, and I showed you how to transfer data from one to other, right. So, let us just summarize the syntax. So, syntax, this is called function definition. So, these are MPI functions. So, MPI functions. Okay. So, MP dot receive. So, there is a communicator. Okay. So, this is like an class. So, there is a function called receive, and we discussed that, well, there are 2 ways to transfer data. There are several others, but we in this class will focus only on 2 ways. So, there is send and receive. So, send. So, one way to send is send an object. So, you need to give the object directly. So, object could be a number, it could be a string, So, object, you have to specify where to send. I mean, envelope without an address is it is not going to go anywhere. So, destination and tag, which I will discuss bit later. Okay. If you have multiple packets, then often it is good to tag them. Okay. Single parcel, you do not need to worry, but if you have multiple parcels, then you need to say tagging it. So, I will illustrate by one program. So, this is sent by one node, one processor is sent. Now, it will be received by another processor, which is receiver. So, this is the destination. So, this is source and this is destination, and these are keywords. Okay. Dest, you should not use a variable, dest is an address, and source is also keyword in MPI. Do not use variable name source. So, wherever, so this guy, this function enables receipt of the data, and that is stored here. You need to return this function. The function returns that data and is stored in receive object. Okay. It can be any, I am just give the name. Okay. So, this is where it is going to be stored, and it is coming from source. You need to specify which source I am getting the address, and tag and status is not required for this. Okay. We will come to status bit later. In fact, today only I will discuss where status is also there. So, this is one way to do it. So, these 2 functions involve objects. I can give the object. So, I think I had said 0 to 1 string. There was a string which was written. So, it is a string I can send a number for 1, 2, 3, 4 like that. Okay. So, this is one way. Second is we can send the address where the data is stored. It is called buffer. Buffer is where I am storing the variable. So, this you send the address of the buffer, not the object itself. So, I could have x equal to 0 to 1 string, and I will put x here. So, I put the variable name. So, that variable is buffer, where we need to send and tag. So, there is a difference between this one and this one. So, first one object was sent, second one buffer is being sent. So, receive. So, in receive you give the address of the variable name itself, not the object. So, variable name will be stored here. So, buffer has to be declared or should be available in all the processors, otherwise there will be an error. Especially if buffer is an array, then you need to declare the array. You can set it to zeros, but array size should be there and the buffer should be declared before. So, I had written buffer based transfer. Okay. So, buffer and syntax is pretty similar. It can come from, it comes from source, which can be any source. There is a tag and status none. None means not required. Okay. And this tag, if you give is okay, if you do not give tag also okay. So, any tag is here and tag default will be 0. So, you no need to specify tag. There is another function which can do receive and send together. This is called send receive. Okay. Send receive. So, you need to give the send object, what is to be sent, where do you want to send, destination, and source, where I want to get it from. So, here I am, so this object acts as source and destination both. So, each processor, among these two processors only involved, each of them send a packet, but receive something as well. So, what you want to send is send object, where you want to send, but I am receiving something. So, I need to give what, which one. So, this second guy, second point I need to give the address, source, and output is saved here, receive object. Okay. We discussed something called deadlock, and deadlock is avoided by the last function. This function will avoid the deadlock, or there is another way to avoid deadlock is you send first, one guy sends and the other guy should receive, then the other guy will send and the first guy will receive. Okay. So, deadlock should be avoided. It turns out in Colab when I ran it there was no deadlock, even if I sent, both of them were sending. So, I think there was some protocol which was handled. So, it's a well, one guy sending is a well, keep it somewhere. So, they may have kept in some temporary buffer and finish the task when you received. Okay. So, I do not know, there are implementations which take care of these anomalies, but normally systems will hang. If you have two send, both are sending and not receiving, then there will be a problem. Okay. So, there is another way to, okay. So, these are 5 functions which are called blocking, send receive. You understand what blocking means? So, blocking means you stop. So, everything stops until these operations are somewhat complete, not fully complete, somewhat complete, right. I told you that for send buffer, as long as the buffer is emptied. So, you please recall there is a interconnect somewhere here, interconnect. So, there is a buffer and from buffer it goes to interconnect. So, this buffer as long as it is not emptied, it will wait. It wants to make sure that whatever packet I sent gets out of the IIT Kanpur post office. Okay. That is what you want to make sure. If it is not, then it is a well, maybe I should just push this post office to send the packet. Okay. So, this is what is the job of this thing, that post office should be out from the local node, and after that it is going in a plane or in a truck, it does not bother. It can, it returns, the function returns and does something else. Similarly, for receive there is a buffer. So, the receiver post office, it is going to Bombay, there is a post office. So, receiver will wait until this buffer is emptied. So, this buffer is emptied and is being copied to the RAM, and while it is copying, it will say, well, things will happen, I am okay now, it can do something else. So, this emptying buffer is what is required for the function to move. Okay. So, these are all part of blocking send and receive. So, things are blocked. In fact, this is very expensive. You are sending large data, then your system is basically just waiting for this transfer to be partially complete. Okay. So, this is as I said, this is expensive, right. I mean, by the way, this could suppose I send 1 megabytes of data or 50 megabytes of data, which is possible. When we do weather simulations, our data sizes are in terabytes. So, there could be data transfer of 1 gigabyte of data could be being transferred. or 100 MB from one node to another node. So, if that is the case, then we do not want to wait to do something while data is being transferred. Of course, we need to make sure that our process is safe. What is meant by safe is, if I need data, it should be available to me when I need it, when I start working. So, the module which is doing the ocean modeling, ocean modeling, simulating the ocean, if it does not get the ocean data properly, or it probably needs the atmosphere data, and if atmosphere data is inaccurate, it did not come and start computing, then there will be a problem, right. I mean, your weather forecast will be totally wrong. So, we need to make sure that the data which is required is reaching the destination. Okay, that is why all this remedies are being taken. So, we will discuss that is called non-blocking. So, that is called non-blocking centricity. I will come to it in after this slide. But before that, testing. How do you test your parallel code? So, these codes which are with MPI, you need to of course install MPI in your machine. So, as I said, you can install for Python MPI 4.py, and for C++, C Fortran, OpenMPI, MPI-CH2 or CS3 right now, you can install. Then only it will work. So, this is a package which needs to be installed. But if you want to test on your laptop, these things will run. If you install properly, these codes will run on your local laptop, even if you have only single core. So, even if you have single core, you can always create process and it will run. It will do in a time sharing mode, which is not efficient. It will be taking time, but you can test your code. If you get the proper result, then you can be happy, but not fully happy. So, what runs on your laptop did not run on the server. The reason being, server has a interconnect, okay, and the data has to go via interconnect. So, sometimes within a laptop, the data is basically sitting in the RAM, you are transferring data. So, some operations may be fully okay, but when you have interconnect, then there could be a problem. Okay. So, some things are okay. Basically, the other guy needs the data, but you did not send in time. Okay. It is going to reach some time, but it did not send in time. In laptop may be okay, but interconnect things are slow and it may cause trouble. Okay. So, synchronization, all that can be a problem. So, you need to test your parallel program on a parallel cluster. So, our computer center has a cluster where you need to test it. Okay. So, we will see once people who are doing MPI, we will give access and you should be able to test it after you test on your laptop or in your in Colab. Colab only we have two processors, which is a problem, but anyway, you first test your code with the Colab, then your laptop, then we move forward. So, that is what I have written it here. So, you can test your code on laptop, but interconnect we need to, I mean the message passing via interconnect is critical and we need to test on HPC system.